We know that in quantum mechanics, we deal with wave functions and waves with many differential equations. There is a very famous differential equation from quantum mechanics known as Schrödinger's equation. When I first saw this equation, it made me uncomfortable because it's very weird. But after understanding the meaning, I am very comfortable with it. The first term is the kinetic energy of the system, second is potential, and the last is total energy. It's just the energy conservation. Kinetic plus potential is equals to total. You can see that potential and total energy is very simple. We just wrote this operator. But why we are writing kinetic energy like this? I was thinking about for a while, and after some thoughts, I was finally able to derive the expression of kinetic energy. And in this video, I am going to show the derivation of kinetic energy I found. So let's start. Okay, so my goal is to find somehow kinetic energy from our classical things to quantum things, which is this. So I want to somehow represent my p square by 2m with this thing. So let's start with some basics of quantum mechanics, some postulates of quantum mechanics. We can represent any quantum system with a wave function. Here our quantum system is a system of particles. Our second postulate is physical quantities like position, momentum, and our kinetic energy also can be represented as mathematical operators. You can also read the third postulate, but we are not going to talk much about it. So I'm not going to care much about the third postulate in this video. So we represent wave function with letter psi, and we can find the probability density of a particle by squaring the modulus of wave function. Our wave function can be complex wave function, so we are taking modulus and then squaring it, which can be also written as taking complex conjugate and then multiplying with that function. Also, from very basics of probability theory, the sum of all probabilities is 1. Similarly, integral of our probability density in entire space is equals to 1. It is known as normalization of wave function. But in this video, I am not going to use these. It's just for some reviewing basics of quantum mechanics. So our wave function was a complex wave function. Yes, it's a literal wave. So I can write my wave function as general complex wave function, which is this, where my kinetic energy is p square by 2m. So now let's try to take a partial differentiation of my wave function, which will be this, which is not very cool. Okay, so let's again take partial differentiation with respect to x of this wave function, which is something cool. If I remove that minus sign in k square, I will get my original wave function. Aha, it's minus k square times my wave function, which looks very cool. Okay, so we know that from de Broglie's wavelength theorem, whatever, momentum is 2 pi h cross h cut whatever divided by wavelength, which is also known as de Broglie wavelength of particles. And also we know that the wave number k is 2 pi by lambda. So from these two things we can conclude that k is equals to p by h cut, h cross whatever. So after taking this value of k and putting into this equation, we will get this thing, And now if I throw minus sign and h cut square to other side of this equation, I will get something interesting. After dividing by 2m, you can clearly observe that, aha, p square by 2m, it's the kinetic energy or kinetic energy operator. So now we can write the kinetic energy operator is same as doing this operation. Or if I generalize this in 3 dimension with similar steps, I will get my original thing which I was supposed to found, which is this. And now I am ready to complete my Schrödinger's equation, which is kinetic energy operator plus potential energy operator is total energy operator or Hamiltonian operator. So now I hope you understand more clearly and more comfortably how this thing is working and how Schrödinger's equation works and why it works. So I hope you liked this video. You can comment your thoughts about this in the comment section or comment another problem for me for next video. Thank you so much for watching. Please subscribe.